I want to work through several examples of the limit comparison test. Here's our first one. But before we get there, I want to talk about a result that's very useful. It's like the soccer commentators in Scotland. A result is very useful here. A very useful result here. It says this. We will use this very, very often. In fact, almost every time when you work with a limit comparison test, this useful result, is going to be very useful to work with the limit comparison test. It says this. If we take the limit as n goes to infinity of f of n, so it's a function of n and a function of n. So that would be f of n, that would be g of n, a function of n and a function of g n, rather. Okay, if the degree, remember the degree is the largest exponent that appears. If the degree of f is equal to the degree of g, if they have the same degree, they do not here, but if they have the same degree, then the limit is equal to, and I'll say it this way, I'll do it conceptually, it is the fraction of leading coefficients. It's the fraction of leading coefficients. If the degrees are equal, then the limit is the fraction of leading coefficients. The leading coefficient is the coefficient of the highest degree term. In this particular case, the leading coefficient here is 1. Leading coefficient here is 3. But this theorem does not apply here because the degrees are not the same. But if you do have the degrees the same, then the limit is easy to compute. It's the fraction of leading coefficients. Essentially, all you would need to do is take this expression and use the associated function and apply L'Hopital's rule, or you could use the technique that you generate from Calculus 1. This is not a particularly challenging result to establish. So what we will do is we will accept that and be able to use that to make our computations a little more streamlined here. So we're going to apply the limit comparison test. So we're going to compare what are we going to compare this against versus? Well, you form, remember, just the dominant term, and more than that, we need the dominant term. When you take dominant term over dominant term, you may ignore the coefficients, because the constant multiplier is just going to multiply along here. If I put this 3 down here, the first thing I do is factor it out and it doesn't enter into the problem in the first place. So when you are finding the series to use for the limit comparison test, you may ignore the coefficients. This simplifies to the series 1 over n to the 4th. This is a p series. With p bigger than 1, this converges. So we know this series converges. I'm going to get rid of this notion. I'm going to say this converges. All right? I want to compare this with that. Limit comparison test. As the name implies, limit comparison test in the actual execution, you actually compute a limit. It's the unknown divided by the known. The unknown divided by the known. Divided by the known. And I'm going to do some algebra. Invert and multiply on the fly. I'm going to multiply by the reciprocal. When you multiply by the reciprocal, well, let's go ahead and put some space here. This is n to the second plus n multiplied by the reciprocal. This is n to the 4th. This is in the denominator. This is 3n to the 6th plus n cubed times 1. Distribute the terms, or the factors here. This is n to the 6th plus n to the 5th over this is 3n to the 6th plus n cubed. And now we're ready to apply this useful result over here. So you may go over here to the right-hand side of the board and get the useful result here. And so we can apply this useful result, because if the degrees are equal, then the limit is equal to the fraction of leading coefficients. I may immediately say this limit is equal to 1/3. This is finite and positive. And the limit comparison test says if that's finite and positive, therefore, I'll say it over here, therefore they agree, and therefore they agree on what? They agree on what you have already written down once, therefore the series converges. All right. So what we'll do is I'll go through a few more examples of this using this useful result, and we'll be able to work through the limit comparison test. That should be, hopefully after a few more examples of this should be a very familiar and tool that you should be able to use.